In this video, I'm going to show you how to find the charges on these two transition metals in these compounds. The first one that we have is HgCrO4. The two ions that this would break up into are Hg and CrO4. Anytime you're trying to find the individual ions for a compound, you need to take the first element, that will be the metal, and that's going to be the first ion. And then everything that's left, you're going to keep it by itself, but together. So don't break this up into three things because there's three different elements. You're going to take the first element and then you write the things that are left. If you have more than one thing left, that means that you have a polyatomic. So you need to make sure that you keep the subscripts of that polyatomic. The one that we have here is CrO4, which is chromate. Chromate has a -2 charge, so I can go ahead and write that here. In this instance, I have a -2 on chromate, and I only have one of those. Be very careful with this 4. You don't want to take the -2 and multiply that by the 4 because they're already taken into account that you have 1 chromium and 4 oxygen to know that the entire charge for this polyatomic is -2. You only have 1 mercury as well. Hg is mercury. Because I only have 1 of each and I need to make sure that the charges are balanced, this has a charge of +2. The next one that we have here is SnSO4. Sn is tin. That metal is my first ion, and then I write what I have left. Again, I take the metal as the first ion, and whatever is left is the second one. This is SO4, and I need to keep the 4. If SO4 was in parentheses and there was a number on the outside, I would not keep that number. I would only keep the 4 because it's inside the parentheses and it's part of one of our polyatomics, being sulfate. The charge on SO4 is -2. And just to show you, we can't find the charge for Sn on the periodic table because if I look here, it has Rn, which means it needs Roman numerals because it can have multiple different charges. This one looks very similar to the one that we just did. We have 1 Sn. It's understood because there's no number here, and we only have 1 SO4. If I had multiple SO4s, this would be in parentheses with a number on the outside. That's not the case. I have 1 of each. So since this is -2, this is +2. Let's fit in one more example here. We can do Fe parentheses C2H3O2. Okay, just to show you what it would look like if we have a number outside the parentheses here. So same thing, I'm going to separate my first element and then everything else that's left. Because this is in parentheses, I do not keep the number on the outside, but all of these subscripts I would keep. So C2H3O2. Keep all of those together. You can double check on your list of polyatomics. That is acetate, and it's right here. C2H3O2, and it has a -1 charge. So I'll go ahead and write that here. And you can also write it here if you'd like. Or if you've already seen the other video, you know that we can also write these separately. I have 1 Fe. It's understood that there's 1 because there's no number here. So there's only 1. And then I have 2 acetates. C2H3O2, I have 2 of those. So I can write these here. You do not have to write this. This is just an extra step to help you understand how and why the charges are what they are. Each of these have a -1 charge. Because each of these have a -1 charge, it doesn't mean I can put just +3 here and then it balances out. I need them to cancel out, and if I put a +1 here, it's only going to cancel this one out, and I would still have an overall charge of this compound being -1, but I want the overall charge to be 0. So then you just think, okay, well, this is -1, this is -1, that's -2 overall. So how do I balance that out? I need the complete opposite. So this side would have to be +2. I only have one of these ions, so that needs to hold the entire +2 charge. If I had multiple of them, then I would have to split the charge up. But in this case, I only have one because there was a 1 here, or an understood 1 here. That means the charge on iron is +2 to balance out with the 2 negative acetates.